Question 21. Cellulose is a polysaccharide which has what? A. Carbon-carbon bonds joining glucose units. B. Hemiacetal links joining glucose units. C. Only beta-1,4 bonds between glucose units. D. Only alpha-1,4 links bonding glucose units. Or E. Both alpha-1,4 and alpha-1,6 bonds between glucose units. The answer is not A, because carbon bonds are what constitute the structure of individual monosaccharides while not being responsible for polysaccharide formation such as cellulose. The answer is not B, because the beta-glucose, which is the monomer in cellulose, forms beta-acetal linkages, not hemiacetal linkages.
The answer is C, because cellulose is a linear polysaccharide polymer with many glucose monosaccharide units. The acetal linkage is from beta-glucose, which makes it different from starch. Therefore, beta-1,4 glycosidic bond is the only bond for cellulose. The answer is not D, because cellulose naturally bonds by the beta-glucose to make the linkage in the linear chain. Therefore, alpha-1,4 cannot be happen with beta-glucose linkage.
21E. The answer is not E, because cellulose is a polysaccharide of glucose units in unbranched chains with beta-1,4 glycosidic bonds only. It does not have the option of alpha-1,4 glycosidic bonds, which is why it is insoluble in water and why humans cannot digest it. Question 22. Amylose is a form of starch which has A. Hemiacetal links joining glucose units. B. Only alpha-1,4 links bonds glucose units. C. Only beta-1,4 bonds between glucose units. D. Both alpha-1,4 and beta-1,4 bonds between glucose units. Or E. Carbon-carbon bonds joining glucose units. 22A. The answer is not A, because amylose consists of 250 to 4,000 alpha-D glucose molecules connected by alpha-1,4 glycosidic bonds in a continuous chain. A hemiacetal compound is formed by formal addition of an alcohol to the carbonyl group. So, these glucose molecules, in their current state, would not be considered hemiacetals.
The reason the answer is a alpha-1,4 glycosidic bond in a continuous chain is because amylose is made up of a 1,4 bounded to a glucose molecule. The carbon atoms on glucose are numbered, starting at the aldehyde, C double bonded to an O, carbon. So in amylose, the one carbon on one glucose molecule is linked to the 4 carbon on the next glucose molecule, which will make it a 1,4 bond. The reason the answer is not only beta-1,4 bonds between glucose units is because the molecule cellulose is made up of repeating beta-1,4 glycosidic bonds, and these are for indigestible foods where our body can't break down. These beta-1,4 glycosidic bonds, unlike the alpha-1,4 glycosidic bonds, force cellulose to form long and sturdy straight chains that can interact with one another through hydrogen bonds to form fibers.
Answer choice D states that amylose is a form of starch which has both alpha 1 and 4 and beta 1 and 4 bonds between glucose units, and that is not true. As you can see in this picture, amylose is a helical polymer that is only consisted of alpha D glucose units. There's no such polymers or polysaccharides that is made up of both alpha and beta 1 and 4 bonds between glucose units. The answer choice E states that amylose is a form of starch which has carbon-to-carbon bonds joining glucose units, and that is also not true. Glycosidic bond for any type of polysaccharides is formed by the condensation reaction. Once the alcohol group from a molecule attacks the aromatic carbon of the sugar, it undergoes a series of reactions, and as a result, the glycosidic bond is formed, which is a sugar molecule linked to another molecule via a ether group, and that is the oxygen atom bonded between the two carbon atoms. So it is not carbon-to-carbon bonds joining the glucose unit. So E is not correct answer.